In question 6, 3 points A, B, and C are such that B is the midpoint of AC. The coordinates of A are 2, m, and the coordinates of B are n, minus 6, where m and n are constants. In part 1, we have to find the coordinates of C in terms of m and n. Now, it is given that B is the midpoint of AC. First, we can add the formula for the midpoint. So that is x1 plus x2 upon 2. And the y coordinate is given by y1 plus y2 upon 2. Now we know that the coordinates for A are 2, m. The coordinates of C are unknown, so we can take that as x and y. And B is the midpoint, so B is n, minus 6. So we can write this as n, minus 6 will be equals to x1 plus x2 upon 2. So we can write it as 2 plus x upon 2, y1 plus y2 upon 2. So that will become m plus y upon 2. Now equating the two equations, so the x coordinate is n for the midpoint, and this is given by 2 plus x upon 2. So we can write 2 plus x upon 2 is equals to n. Cross multiplying, we'll get x is equals to 2n, and this is x plus 2. So x will be equals to 2n minus 2. For the y coordinate, the midpoint of the y coordinate is minus 6. So we can write it as m plus y upon 2 is equals to minus 6. Cross multiplying, we'll get m plus y is equals to minus 12. So the y coordinate of C will be minus 12 minus m. In part 2, it says that the line y equals to x plus 1 passes through AC and is through C and is perpendicular to AB. We have to find the values of m. Now, as this line is passing through C, we can see that if the equation is y equals to x plus 1, so the coefficient of x is 1, which is the gradient, as we have our equation in the terms y equals to mx plus c. Now, if this line has a gradient of 1 and it is perpendicular to AB, so the gradient of AB will be the negative reciprocal. So if two lines are perpendicular, the gradients are negative reciprocal, which means that the gradient of AB will be minus 1, as the line is perpendicular and it is passing through C. And this has an equation of y equals to x plus 1, which means that the gradient is 1. So the gradient of line AB will be equals to minus 1. Now we can make first an equation with the gradient of AB. We know that the coordinates are 2, m and n, minus 6. The gradient formula is y2 minus y1 upon x2 minus x1. So we can take it as minus 6 minus m. So minus 6 minus m, y2 minus y1, and x2 minus x1 will become n minus 2. So dividing this by n minus 2, and that will be equals to minus 1. Cross multiplying, we'll get minus n plus 2 is equals to minus 6 minus m. Taking the m on the left hand side, we'll get m minus n is equals to minus 6 minus 2, which is equals to minus 8. So we have the first equation over here. And to find the second equation, as we know that this line y is equals to x plus 1 is passing through C, and we know that the x coordinate of C is given by 2n minus 2, and the y coordinate is minus 12 minus m. So we can write, in place of y, we can write minus 12 minus m, and in place of x, we can write 2n minus 2. So this will become minus 12 minus m is equals to 2n minus 1. Simplifying this, taking n on the left hand side, we can write this as minus 2n minus m is equals to minus 1 plus 12. Simplifying this, we'll get minus 2n minus m is equals to positive 11. Once we have this equation now, so yes, this will become positive 11. Now this is our second equation. Now we can find the values of m and n by solving these equations simultaneously. So this is m minus n is equals to minus 8. We can rearrange this to write it as minus m minus 2n is equals to 11. This will cancel out. We'll get minus 3n is equals to minus 8 plus 11. So that will be equals to positive 3. So n will be equals to minus 1. Once we have the value of n, we can find the value of m. So we can use either of the equations that we have. So m minus n is equals to minus 8. Substituting m as minus 1. So this will become m plus 1 is equals to minus 8. So m will be equals to -8 minus 1. So m will be equals to -9. So the two values for m it will be -9 and for n it will be equals to -1.